Now we have this problem. It is asked that there is a car which is 2 meter long and 3 meter wide. It is moving at 13 meter per second. When the bullet, it is hitting in a direction meaning angle theta is equal to tan inverse 3 by 4. It strikes over here. It enters one edge, and due to the velocity, relative velocity, it comes out of the diagonally opposite corner, means from right here. So it is asking that the time of the bullet to cross the car. Okay, so now we are going to use the concept of relative velocity. We will be viewing the motion of the bullet from the car frame. So let's do it. Let's write this. This is the car. This is moving at 13 meter per second. This is 2 meters. This is 3 meters. This is the V and making the angle theta. So we will now make the center of the car frame at rest. So let's see what happens to the velocity of the bullet. So if this is V, this theta, then this is V cos theta, and this is V sin theta. We are making the car frame at rest, so we need to give 13 meter per second velocity over here. Okay, so now it is asked that this bullet will travel to this corner, so we are taking the V sin theta component and equating it. So we have t equals to distance traversed by velocity, so this is equal to this distance, which is 3 meter by V sin theta. Okay, and same applies to this part also. T equals to 2 by V cos theta minus 13. From here, solving these two equations, we can absolutely get this one formula, that T is equal to 1 by 13 into 3 by tan theta minus 2. Here tan theta is equal to 3 by 4, so let's solve this. 1 by 13, 3 into 4 minus 2, so this got cancelled. This is 2 by 13, approximately is equal to 0.15 seconds. So the answer is option C, which is already marked here. Okay, now we have this question. I think the observant viewers can argue that this question is taken from Herodov. So let's solve this question. It is given that two boats, A and B, they are moving away from a buoy anchored in the middle of the river along the mutually perpendicular straight lines. This line is very important. Boat A goes along the river and boat B goes across the river. After moving off equal distance, the boats return. It is asked to find the ratio of times of motion TA by TB if the velocity of each boat is 1.2 times greater than stream velocity. So let's solve this question. Let's suppose this is the river and this is the boat A. So A will move off an equal distance d. Stream velocity is u. Let's assume this as u, and this moves at v. So the time taken is d by v plus u for the first leg of the trip, and when it is coming back, it is moving upstream, so this will cause resistance, so it is plus d by v minus u. Okay, now talking about the boat B, is going to move across the river. So let's assume that this is the stream velocity u, this is the velocity of the boat V. Suppose this makes an angle theta. Now it is given mutually perpendicular straight lines, so the boat must move along this direction. Okay, so we have, this is v cos theta. Horizontally there will be no velocity component, so we have u is equal to v cos theta, and this is then v sin theta. So here we have v sin theta, so the time taken is d by v sin theta, both for the upper leg and the lower leg of the journey. So we have into 2, which is 2d by v sin theta. Okay, now we are going to have an expression for the sin theta. Squaring this expression, u square is equal to v square cos square theta, then u square by v square is equal to cos square theta. We can write this as 1 minus sine square theta equal to u square by v square. Sine square theta is equal to 1 minus u square by v square. So we have sine theta is equal to, this is equal to u square, v square minus u square root under by v. Okay. So the time taken was given t a. We found out this is d by v plus u plus d by v minus u. Time taken by the b is equal to this is 2d by v into, let's substitute sin theta, v square minus u square by v. This gets cancelled. Now we are going to find the ratio Ta by Tb. This will be equal to d into, we are taking the d common, 1 by v plus u plus 1 by v minus u, and this is 2d by root under v square minus u square. Now it is given in the question that velocity with each ball with respect to water is 1.2 times greater than stream velocity. So v is equal to 1.2 u. We will substitute this in the ratio. This will give the answer Ta by Tb is equal to 1.8. This is a very big calculation, so I am leaving it to do for the student. Next we have this question. Is given that the radius of the front and the rear wheels of the carriage are A and B. So let's try to do this. This is it. It's given that front wheel, this is A, let's suppose, and this is P, let's suppose. So we are going to mark the centers here, of course. This is the horizontal line, and this distance is given as C. C is the distance between the front and rear axle. This is C. So the horizontal distance, we can find it as root under C square minus A minus B whole square. Okay. So now for the circular rolling motion, we have, it is in the pure kind of rolling, this is 0 velocity, center of mass moving at v velocity, and topmost particle moves at the 2v velocity. Okay. So the particle of dust is driven from the highest point of the rear wheel. It will go with the 2v velocity, and this axle, this entire apparatus, it is moving at the v velocity. Okay. So we can tell that with respect to the cm frame of this apparatus, the particle is moving with an effective velocity of 2v minus v, which is given as v. Okay. So we are going to solve this question. So now, after calculating the horizontal distance, we can also calculate the vertical distance the particle must traverse. So let's try to draw this figure again. Yes, vertical distance can be given as this. Since this is radius A, it is 2a, and this is radius B, this is also 2b. So this distance, this will be given as 2a minus b, right? So the time taken of is, we can also do the time concept, or we can also solve by the distance concept. Distance traversed over here is c square plus a minus b whole square. So we are going to write this square minus a minus b whole square. This is equivalent to velocity, this horizontal velocity, into 2 into 2b minus a by g. So we have root under c square minus a minus b whole square is equal to v root under 4b minus a by g. From here we can calculate the velocity. Okay. This question, it is given that this arrangement of the rigid links of equal length L, they can freely rotate about the joined ends. This R, U, Q. The end is U is pulled horizontally with constant speed 20 meter per second. It is asked the speed of NDP when the angle SUT is 90 degree. So let's draw this figure. We have this and this. These rods can move about these joints. This is moving at the velocity 20 meter per second. This is the end u, this is the end r, and we are asked to find the velocity of this end p. Okay, so first of all we will try to find the velocity of this end r. This rigid link apparatus, here we can say that the distance traversed by the u in an expansion is twice the distance traversed by the end r in the same expansion. So we can write that xu is equal to 2 into xr. We can differentiate this equation. Dxu dt is equal to 2 dxr dt. So we have vu is equal to 2 into vr, which means that the velocity of r becomes half that of the velocity of u. So it means that this the end u is moving with 20 meter per second, the end r will move with 10 meter per second velocity. So now let's try to find the velocity of the end p. So let's draw this again. This is the end p. This end p can be assumed to act along this line. So let's try to assume that this end of velocity moves the u. So now this end is moving at 10 meter per second. Since these rods are assumed to be inextensible, there is no relative motion between the points of the rod. So if this moves with 10 meter per second, this component along the rod will move with 10 cos 45, because this angle is 90 degrees, so half of 90 is 45 degrees, so we have 10 cos 45 degree. This will be equal to the end u velocity, so u is equal to 10 cos 45. This is equal to 10 by root 2, which is equal to 5 root 2. This is equal to 5 into 1.4, which is 7 point something meter per second. So you can write that as 7.1 meter per second approximately. So we have option C, so it's correct. Next we have this question. It is given that there are 6 particles which are situated at the corners of a regular hexagon. These move with a constant speed v towards the other particle. They maintain their direction. Side of the hexagon is A. It is asked that the time the particles will take to meet each other. Now we can use the concept of average velocity. First of all, let's try to analyze the motion of these particles. When these particles are moving initially, they will move like this. When the particle comes here, this will try to follow its path like this. This will go 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 like this. So they will try to follow a spiraling motion, which is eventually going to meet at the geometrical center of the hexagon. So let's try to solve this problem. So we have this. Initially the velocity is directed towards this end v. This is an equilateral triangle of side A, so this is also A, this is also A, this is of course 60 degree. Okay, so the component of the velocity along this line can be given as v cos 60. So time taken is equal to distance traversed by velocity, which is equal to A by v cos 60. So this is equal to 2A by v. Okay, so now we have used this concept because we can assume that instead of going around this spiraling motion, the particle just moves along this line and eventually merges at the center. So we have taken the component of velocity and taken the effective distance. So we have the answer T is equal to 2A by v. Next up we have this problem. This is yet again a problem based on the concept of constrained motion. This is a snapshot of a petrol engine. This is of course the crankshaft. So it is asked to find the angular velocity of the shaft. This piston moves down with the velocity 40 root 3, angle is 30 degree, and this moves with the omega. We have to find this omega, of course. This angle is 120 degree. So let's try to solve this problem. First of all, we will try to draw this apparatus. This is the piston. It moves like this. Okay, this is a pretty bad diagram, so you can ignore it. This moves down with velocity of 40 root 3 meter per second. This rod is inextensible, so the component of this velocity along this rod is 40 root 3 cos 30. And now let's try to analyze the motion around here. Let's try to draw this rod once again. This goes like this. So now we are going to give this velocity as v approximately. This is the tangent. The omega is equal to v by r. So let's say that let's assume that this omega equal to u by r. This end is u, this end is v. V along the rod is equal to 40 root 3 cos 30. Since, as I mentioned, the rod is inextensible, so we have v is equal to 40 root 3 cos 30 degree. This end u has also a component of velocity along this rod. This angle is also 30 degree because this is 120 degree. This entire angle is 60 degree, and this is the splitting, so this is 30 and this is 30. So we have this angle as 30 degree. The component is u cos 30, u cos 30 degree. So we can equate the two velocities. We can use u cos 30 is equal to 40 root 3 cos 30. So we have u is equal to 40 root 3 meter per second, of course. So we can use omega equal to u by r. U have calculated 40 root 3 by radius, which is given as 40 root 3 centimeter. So we will divide it by 100, sorry, I apologize. So this will be 100 radian per second. Now the problem with this question is that in the Physics Galaxy book, this question is actually solved a bit wrongly. So the option is not matching, but this is the correct answer. I have referred to a lot of sources. This is the final correct answer. Okay. And last we have this problem. It is shown the hemisphere and a supported rod. It is moving in the right direction with uniform velocity v2, and the end of rod in contact with ground is moving in left direction velocity v1. So this moves with v1, this moves with v2. It is asked to find the rate at which the angle theta is changing in terms of v1, v2, r and theta. So now the rate at which angle theta is changing means we have to find the value of d theta dt. Okay. So now we can solve this problem as, let's try to do this and this moves with v2, this moves with v1. So here in the center of mass frame with the hemisphere respectively, we can say that this rod moves with v1 plus v2 velocity. Okay, let's assume that if this is r, it traverses a distance x is equal to r cosec theta. You can get this from trigonometry. We can then try to differentiate this as dx dt is equal to r into minus cosec theta cot theta to d theta dt. So we have this dx dt, which I told you it is v1 plus v2. So this is v1 plus v2 is equal to r into minus cosec theta cot theta into d theta dt. So we have d theta dt is equal to v1 plus v2 by r into cosec theta cot theta. We must put the negative sign, which means that the angle theta is decreasing. So this was my list of problems with you. Thanks for watching.